So now we'll start the chapter Dimensional and Error Analysis. So first we'll see what is a physical quantity. Any number that is used to describe a physical phenomenon quantitatively is called a physical quantity. Now how do we measure a physical quantity? So basically measurement of a physical quantity is a comparison process. What we do is we try to find out how many times a standard amount of that physical quantity is present in the quantity being measured. So the number thus obtained is known as the magnitude, and the standard chosen for comparison is called the unit of the measurement. Now let's talk about the standard which is used for measuring a physical quantity. So when we measure a quantity, we always compare it with some reference standard which does not change. So a standard should be invariable, it should be easily accessible, it should be precise, and it should be universally agreed upon. Now we'll see what is a unit. The unit of a physical quantity is a value of it in terms of which other quantities of that kind are expressed. Now what is a system of units? There are three popular system of units. First one is CJ system, where the unit of length, mass and time are centimeter, gram and second respectively. The other one is FPS system, where the units of length, mass and time are foot, pound and second respectively. And the third one is SI system. Here the unit of length, mass and time are meter, kilogram and second. The SI system is also called the standard system, the standard international system of units, and this is the unit which is widely used. Now we'll see what are the fundamental quantities and what are their SI units. A fundamental physical quantity is the quantity which does not depend on any other physical quantity. In the SI system we have 7 fundamental quantities. They are length, mass, time, electric current, temperature, amount of substance and luminous intensity. So for example, the unit of length is meter in the SI system. Similarly, the unit of mass is kilogram, that of time is second, that of electric current is ampere, that of temperature is Kelvin, that of amount of substance is mole, and that of luminous intensity is candela. And the dimension of length is L within the square bracket. Similarly, the dimension of mass is M within the square bracket, and similarly for the other physical quantities. In addition to these 7 physical quantities, we have 2 supplementary quantities, which are angle in a plane, which has the unit radian, and the solid angle, which has a unit steradian. Now we can have the definition of various SI units of fundamental quantities. So for example, the meter is defined as 1650763.73 wavelengths of radiation corresponding to orange red light of krypton 86 in free space. Similarly, we have the definitions of second, kilogram, ampere and Kelvin. And mole, candela, radian and steradian. So you need to go through these definition. These are the standard definition of SI units of fundamental quantities. Now we'll see what are the prefixes for SI units. So we have a table here. For example, you can write 5000 gram as 5 into 10 to the power 3 gram, and the prefix for 10 to the power 3 is kilo, so you can write it as 5 kilogram. Similarly, 5 into 10 to the power 6 gram can be written as 5 megagram. Or for example, 2 into 10 to the power minus 12 second can be written as 2 picosecond, as the prefix for 10 to the power minus